Hello, good Friday morning, everybody. Welcome to the Backyard Naturalist, which is brought to you by the Urban Ecology Center right here in Milwaukee. My name is Tim. I am honored to be the host for this week's episode. It's the middle of November, my absolute favorite time of year. It starts to get cold outside, the darkness is returning. And for today's episode, we are moving objectively far outside of our backyard naturalist box, but I think that's okay. We're still telling stories from the natural history perspective, so there's the naturalist part, but the subject is not exactly in most people's backyards, although here in Milwaukee we can find octopuses sometimes over at the zoo or over at Discovery World. And I think Larry mentioned quite a while ago, we're really gone beyond the backyard borders anyway, so breaking them wide open. And if your backyard happens to be on a coast, then it's not too much of a stretch. But this is more of a pure fun and nature's amazing episode. And we will have more of these in the future because today it's octopuses and they're equally fun stories to tell about squids and jellyfish and other aquatic invertebrates along with everything else. So I am ready to dive into the wet and wonderful world of the octopodes. And as usual with the Nod to PBS, we appreciate you, our viewers, and fellow travelers on this journey of learning with an extra special nod to our subscribers. Thank you so much for your support. We really appreciate you. And in less than 3 months, we'll be teaching our next course, which is Winter Ecology, which will be taking place in February, right after the opening of the newly renovated Washington Park branch of the Urban Ecology Center. So we hope you can make it to the grand reopening. The building is amazing. We'd love to see you in person there, and we'd love to see you at the Winter Ecology course. And there will be snacks every week, I promise. And not much new to report from the astronomy side of things, but we're 2 days away from the peak of the Leonids, and we're also early in the Orionid meteor showers. So this is just a time of year where it's if you can deal with it, and it gets dark earlier, so it's easier to stay up or wake up earlier and look for meteor showers in a warm, dark place. And with that, we'll kind of get right down to today's somewhat unexpected featured organism, the octopus, and why this episode is called Octopodes, because of the age-old question, what do you call it when there is more than one octopus? From a purely grammatical standpoint, I've got my Carolyn Washburn talking to me here. The correct plural of octopus is octopuses. If you say, look at those cute octopuses, you are grammatically correct from the United States of America. I think it's easy to try to make the connection that a group of octopuses should be octopi. It's a little more fun, maybe makes you sound a little cooler, but technically speaking, that's wrong. And the reason that it's wrong, uh, I'm sure I'm getting a little bit of eye rolling here, but for those of you that do geek out at this thing, to pluralize a word by adding the letter I applies to words with Latin roots. So the plural for cactus, a word with a Latin root, you can quickly say, look at those cute cacti. Octopus is derived, however, from Greek. And the correct way to pluralize words with Greek roots is to add the suffix odes. So octopodes, octopodes, that would technically be the correct way of saying octopuses, but octopus is a English formulation of the Greek word, and in English, plurals are made with the good old S or ES. So the grammaticists say we should be saying octopuses. Of the three ways to say it, I like octopodes best. Mike Larson likes octopodes best. I admire Mike Larson. Octopi is the least correct, but I think it's okay to say whatever you want, and people will know, and I think it's fine. And I am not on the grammar police, and um, so call them what you want. Incidentally, for the same reasons that we call octopuses, there would be a group of rhinoceroses, not rhinoceri, maybe rhinocerodes, or just rhinos. But here's the octopus. And for all of the remarkable features of the octopus, for all of the amazing stories. They are extremely solitary, so at the end of the day, we really don't have to worry too much about what the plural is because it's an extremely rare situation where you have more than one anyway, and you have to think of the right word. So the octopus is a good old eukaryotic animal. It's part of the mollusk phylum, along with snails and slugs and clams and chitons. So in the octopus big old family reunion where they all see their cousins, these are the animals who show up. And the octopus is distantly related to all of these things. And we've featured both snails and slugs in previous episodes. So you can go back to, it's called the good leopard slug. I think we really get into what mollusks are. It's a very large, very important to humans and important to the world group of animals. It This group has some of the most deadly animals, both poisonous and venomous. And of course, that means if they're poisonous and venomous, they're also being studied for scientific advances in the medical fields. They are invertebrates. Their soft body is composed almost entirely of muscle. These are, for their size, very strong animals. They have a mantle, and the mantle is a cavity that hosts all of their bodily functions. Looking at you, Tori. They have a nervous system, but yeah, they're strong. They can stick to objects very with a lot of strength. They can keep their shells closed, and it's mostly muscle. Their body is mostly muscle. From the phylum, we go to the cephalopods, and that translates as head foot. And this group is new to the backyard naturalist community, at least from past episodes. Head foot, head footed. Objectively, I think this is maybe the coolest group of animals on the planet, at least top three. And if you look at the basic body plan, it does kind of look like this is a group of organisms with a head and feet. The feet are a set of arms or tentacles that are modified from the same foot structure that you see in snails. So you can think of it as like a snail without the shell with lots of feet. But that large bulb you see with, and as a kid, I and maybe others kind of makes that the bulb makes it looks like the head because it's got the eye in that head, and it kind of, I mean, we try to make things look familiar to us. To me, it looks like that's the head. It's not. It's the mantle, and that contains all of the internal organisms. Really, the head is just kind of smushed in between the top and the bottom where the mouth is. There's really not much of a head. So, um, the mantle, again, everything that is important internally is in that mantle, in that bulb. So the digestive system, the reproductive system, the excretory system, extremely strong muscles though throughout the body systems, including the mantle. And the that helps with breathing. It helps with so many other body functions. It helps with defense. It helps with offense. They are, even though they kind of look radially symmetrical, they're bilaterally symmetrical. If they're symmetrical, like we are. Sometimes this group is known as the inkfish for their ability to shoot and produce ink. The study of mollusks is called malacology. The study of cephalopods is known as teutology, Teutholgy. And this is a group that was pretty dominant during the Ordovician period. So there was a time, there was a time of the fish, there was a time of the dinosaurs, there was a time of the trees, there was also a time when cephalopods were dominant. And a lot of what we know from or about cephalopods is from the fossil record. Unlike a lot of invertebrates, the cephalopod shells, for the most part, were strong calcium. We're able to persist as fossils, so we didn't lose a lot of that, particularly the nautiloids. And that huge diverse group today is represented by two much smaller groups or subclasses that have anybody left from all of the the fossils from all of the old extinct organisms. There's two groups left today. There's the nautiloids, and they have retained that external shell. They were, again, one of the top predators in the past. And one of my favorite Milwaukee Public Museum exhibit, that Silurian reef, has some ancient nautiloids They're no longer with us today, but a huge diversity, and it's kind of nice that the huge diversity of organisms also left a huge diversity of shells, and the shells are all different shapes, sizes, colors, and we do still have some nautiloids today. One of the coolest nature sightings for me ever was seeing a nautilus in the ocean while snorkeling, and it's just one of the coolest animals on the planet. This is not where octopuses are. Octopuses are with the coleoids, and generally this is represented by octopuses, squids, and cuttlefish. And this group has lost that rigid outer shell that the nautilus has. Most still have an internal shell structure called a cuttle bone, and that's used to anchor muscles, and it's used for buoyancy, and again gives us some nice fossils. But most octopuses have lost that shell structure altogether. And somebody at the beginning was saying all they have left really from a hard fossilizable structure is the beak. So from there, the octopuses separate from the squids and cuttlefish and from the superorder Octopodiformes. And the order, let's see, the octopus's order, it means 8 foot. Octopus, 8 foot. All octopuses have 8 feet. Um, Again, we consider them feet. You could consider them appendages. You could, whatever you call them. It doesn't matter to the octopus if we call them arms or legs or feet. Then the octopuses have either lost or modified the two extra tentacles that you have in squids. And um, so squids are considered to have 10 feet or arms, and they're the decapods. Octopuses have 8, so they're the octopods. And then one of the other major distinguishing features between the squid on the left and the octopus on the upper right is that the octopuses, for the most part, have those suckers, those suction cups throughout their legs or feet or whatever you're going to call them. There is one squid that is included in the octopus order, octopod order, and it's called a squid colloquially, but it probably because it looks more like a squid than an octopus, but phylogenetically it's related to octopuses, and so we call it the vampire squid. Super cool. Look it up. Its Latin name translates as the vampire from hell, and you can also see that root word tooth in its Latin name, which refers to the cephalopods. Extremely deep sea animal. It's bioluminescent, totally unique metabolism, and it's most closely related to octopuses, so it's in that order, but it's distinguished by that little pair of arms on its dorsal side that you can see, and so it's in its own order. It's the only surviving example from that order, Vampiromorphida, and just super cool, strange cousin of the octopus. But this is where we begin our journey with this group of 8-footed mollusks, and um, this is not going to be super linear. This is going to be more of like octopuses are so cool, and here's the million reasons why, and we'll kind of jump from super cool thing to super cool thing. So won't read like a novel. It's more like an almanac or a reference book. But if you're looking for a YouTube rabbit hole to remove yourself from the world, from reality a little while, just start looking up octopus camouflage, and um, we'll show some links at the end. We'll link those videos that we can't show you because of the copyright police. But uh, and if you need those links, you can. And you're not on our email list, you can contact me, Tim, on the Urban Ecology Center webpage. But octopus camouflage is just incredible. It's a thing of beauty. It's a thing of mystery. It's a thing of mastery. It's been very well studied, yet we still don't know a lot, particularly about how octopuses use the camouflage. We know a little bit about the mechanics behind it. We know a little bit how it works, but in terms of how the octopus controls it and uses it, we still don't know a lot. But it starts with cells called chromatophores, and these are little cells that each contain 3 tiny pigment sacs. And there's some things in our eyes that also contain 3 tiny pigment colors. We call them cones. But there are tens of thousands of these spread throughout the octopus body, and each one is controlled by its own nerve. So Each nerve controls its own muscle, and so by expanding or contracting individually these tens of thousands of chromatophores to different degrees, then each chromatophore can present its own particular color. That alone is like a mic drop. That's incredibly amazing. They have a tremendous degree of control in how the colors of their body present themselves. But that's just one layer to this amazing camouflage. They have reflective cells on their skin called iridophores, and those act like tiny little mirrors that allow them to kind of reflect the surrounding colors. It's like the I don't know, you see that in the movies, the kind of camouflage like in Predator or uh, Harry Potter, probably the cloak is probably something like that, reflecting the surroundings. Um, so the chromatophores produce color, the iridophores reflect color from the surroundings, and then those two together are able to make incredibly accurate, enhanced, accentuated images of their surroundings. And then it doesn't stop there. There's also things called their skin projections that are called papillae, and that allows the octopus skin to change its texture in addition to the color. And they're able to max the texture to the surroundings. So if it's on a smooth surface, the octopus can make its skin smooth. If it's on a bumpy surface, the octopus can make its skin bumpy. It can basically become its surroundings. And then there's a further step in how it controls its body itself. So it can make its body shape, in addition to those little tiny papillae, it can make its shape flat, it can make its shape, it can turn itself into a coral reef rock, like the image in the below in the image below. And it's it's not just rocks or living things that they can do impressions of, they can imitate living things and imitate them not just in shape but in behavior. So this is the brown octopus, which is, you know, ordinary octopus, good predator, good at camouflage. The brown octopus does have an Achilles heel. The brown octopus and the damselfish just do not like each other. They're like the Hatfields and the McCoys. They don't eat each other. But for whatever reason, well, and certainly damselfish don't eat octopus. I'm sure an octopus would eat a damselfish, but for whatever reason, the damselfish really like to harass the octopuses. It's like crows mobbing a hawk, maybe because they could get eaten. And so damselfish will just annoy the heck out of the octopus until the octopus gets out of town. But the brown octopus has its own little secret, or knows its own little secret, because sea snakes are a natural predator on the damselfish. So if a sea snake comes along, the brown octopus is very happy because then the pesky damselfish will leave. But the octopus, being amazing, doesn't have to wait for an actual sea snake to come around. When it's had enough of that damselfish pestering, it's like, okay, guys, I'll be back. Goes off to the phone booth, comes back, and it is a sea snake in disguise. I think I missed that. I'm sorry, I'll have to put that in later. There's an amazing picture of a sea snake disguised as, or an octopus disguised as a sea snake. Its body is buried in the sand, and it's got two little, um, it only has two of its legs out, looking and swimming like a sea snake. It is extremely uh, effective. And, you know, because octopuses are extremely solitary, it probably just likes to hang out in this form for a while, because then there's probably a lot of other things that wouldn't want to mess with the highly venomous sea snake. So gives the octopus a chance to be left in peace. I don't think anyone would argue that the octopuses are the goats of camouflage, and goat, I'm referring to greatest of all time, with the chromatophores, iridophores, papillae, and the ability to shape shift. But they also are literally the goats of the world because their eyes look just like goat eyes, pretty much the same. So discussion is over. They are the goats of camouflage. And this camouflage color change takes place in a third of a second or less. And you'll see that in the video, how quickly they can change colors to match their surroundings. So moving on from octopus camouflage, we will move on to octopus blood. Octopus blood is blue. Ours is red. This is a little more straightforward. Our blood is red because we have iron-based proteins called hemoglobin that binds with the oxygen in our bloodstream. Octopuses have a copper-based protein called hemocyanin. Cyan is Greek for blue. And you've probably witnessed copper pennies turning blue in oxidization. Um, and even the Statue of Liberty, which has copper in it, gets a blue haze because of the copper. So it's in, so hemoglobin is red, hemocyanin is blue, or for those reasons. And the other thing that's important to know is that hemoglobin is quite a bit more efficient than hemocyanin, where our blood is much better at bringing oxygen to our body. And what that means then is there's a lower concentration of oxygen in the blood of octopuses, which means octopuses need a circulatory boost. And for anybody that has seen Finding Dory, we know that boost comes from the two extra hearts in their body. So they have three hearts. And that's because of that low oxygen concentration from the less efficient hemocyanin. So one heart pumps blood to each of the two gills, so that's two, and then there's a third heart that pumps blood to the rest of the body. Then, so we know there's blood, there's also octopus ink. Octopuses, like squids, can eject ink. And even ink ejection isn't just an ejection. It's not just an ink ejection, probably better call it a fart, isn't just the same. So octopuses can control how much and how concentrated the ink is. They can mix it with water. They can eject little globules of ink as decoys. And the main use of ink is to evade and escape. So it's a little smoke bomb on the stage that lets the villain escape. And it's not just like if you're a shark and you're trying to eat a octopus and it squirts ink. It's not just that all of a sudden you can't see. The ink also contains triocyanase, and that gets all up in the business of your face and makes you really uncomfortable. It impairs your sense of smell. It impairs your sense of taste. Just kind of like really disorients you. And the predators don't like that. Get super bent out of shape. Want to get out of there as quickly as possible. It also gives the octopus plenty of time to slip away. And then I would imagine that, for a lot of predators that don't want that experience again, there's probably some learning going on, like, oh, maybe I shouldn't mess with that octopus anymore. And the ink cloud isn't always necessary because, as I mentioned at the beginning, octopuses are very strong. They're pure muscle and they're pretty good at defending themselves on their own. So they we think of them as these kind of fluid blobs, like these breakdancing blobs that can just kind of like, but they can turn those arms into arms that are just like ours. They can make them rigid. They can make them bend at joints like they have elbows, and so they're under an extreme amount of control. They can use them, we'll see, as tools, as defense mechanisms, and they're really, really strong. Like we know those bean vines were strong. We know snakes are strong. Octopuses are really, really strong. And that's another good YouTube uh, rabbit hole to get into is to look at octopus interactions with shark. And you see, you'd usually put your money on the shark, but octopuses are no joke. They're incredibly strong. And with all of these things they already have going with it, the camouflage, the ink, their strength, um, their mouth is also really, really, really scary. So here's one battling with a shark. Um, Octopuses love clams. Clams are very strong on their own, so it takes a lot of effort to force open a clam shell for most things. For octopuses are like, whatever. This is like, have you seen my guns? This is going to be easy. So they use their incredible strength to open up clams pretty much just like you would want to. And then they have that one really hard structure is their beak. Their beak is also no joke. It's similar to a parrot beak, incredibly strong muscles that are kind of like lips around it that can control it. And once they get the shell open, they've got this barbed tongue called a radula, which most mollusks have. And then after it gets it open, it uses that tongue to scrape out the meat. And I'm sure this has got to be the basis of a lot of clam horror movies, and has to at least be the inspiration for the Alien series, where it's like a uh, and this you'll see this kind of similarity even further, because so it's got the strong lips, it's got the strong beak, a strong tongue, and then it has something called radula. Uh, I'm sorry, the radula is the tongue. It's got something called a salivary papilla. And this is, you can kind of see it in the very bottom of the upper left picture here, or diagram here. You see the beak, you see the radula, and then kind of sneaking under it, and this is where that alien tooth imagery comes, is this salivary papilla. It can literally shoot out of the beak like the alien teeth, and it's able to drill into the shells of clams or other seafood. And it's not just a physical drilling motion, it's also chemicals that are shooting out at the same time to erode that calcium. So there's pretty much not much of a chance for anything to survive. It's the mouth of the octopus is like a Swiss Army knife. It's got all these different tools, kind of like a dentist, all these sharp things that it wants to shoot at you. And you can find a lot of images of pretty tough looking shells that have holes just drilled through them like it was through a drill press. And that comes from the drilling motion of, which is like the third or fourth option of the octopus trying to hurt you. It's got all these other things, and there's like, all right, I can't use any of these. I'm going to drill through you. So you pretty much have no chance. And combine that with those strong, deadly legs that are really strong, that can trap you first. They are pretty amazing predators in their own right. And just another cool fact, they're really efficient at metabolizing their food. Upon an octopus's deathbed, which happens after it mates, the octopus weighs roughly 1/3 of the weight of all the food that it's ever eaten in its entire life. And I don't know what the equivalent is in humans, but it's got to be tiny, tiny, tiny. If you live, 70, 80 years and think of all the food that you've eaten and how much you weigh at the end of your life, it's got to be tiny, tiny fraction. For octopus, it's only 1/3 of the weight of all the food that it's ever eaten, which is, and really shows how efficient they are in using the food that they eat for their own metabolism. So, uh, for for all of this amazement, for all of this incredible predatory behavior, they are incredibly solitary. Pretty much the only time an octopus will ever interact with another octopus, unless it's in some kind of aquarium, is when they mate during reproduction and when they're born and they quickly wave hi and bye to mom. So, for that brief moment when an octopus is forced to interact with another during reproduction, it might go as you would imagine between animals with lots of arms. Essentially, the male takes his spermatophore and deposits it inside the female cavity. There is evidence of courtship in some species. There are color changes, there can be ritual movements, but the spermatophore actually, it might go into the female cavity. So that's one option, is that he puts it into the cavity and then it just kind of sits there until it's needed. And um, when she needs it, the spermatophore, she will literally put one of her own arms into her cavity and take it out and use it as a tool to uh, to fertilize the eggs. And it's just really crazy and funny and scary to think of that happening. Um, if the spermatophore doesn't go into the oviduct, it will go into, I'm sorry, into the if it doesn't go into the cavity, it will go into her oviduct. And then that's a little more straightforward, because then as the eggs are going through the oviduct, they're fertilized internally with that with the spermatophore. Sometimes the male will, depending on where whether he puts it in the cavity or the oviduct, sometimes he will first, like many other animals, put another arm in there and just check to see if there's any other sperm in there, and if it is, he'll scoop it out. to make sure that his own sperm is the only one in there. And there are a lot of interesting stories of octopus reproduction. You can also look down that rabbit hole carefully. But there's one story that is just it towers over them all, or hides from them, depending on who you look at. And we will tell the story of the blanket octopus. Some people call it the pillow octopus. Either way, pillow blanket, cute, cuddly. And another word to describe it is tiny. In this picture, it's huge, but in reality, it's about a 2 centimeter long octopus, a deep sea octopus, weighing less than a gram. So that is the blanket octopus. Let's meet another blanket octopus. This is the female blanket octopus. I tried to put him on the lower left and her on the upper right. The Where he is 2 centimeters long and less than a gram, she is 6 feet long and weighs about 100 pounds. She is 40,000 times the size of the male of her species. Bear with me on a very odd journey of the imagination, but if you do scale that to humans, that would be a an average human male pairing up with a female that is 4 times as large as the Statue of Liberty. Same species. So I think even like what I have pictured here is the male should be much, much smaller than that. Um, so you can imagine mating might be difficult in that. Um, and the way around that is the male actually, so he, just like other octopuses, will scoop up his spermatophore, and then he will just take that, he'll swim up to where it needs to be deposited in the female, and then he just essentially takes that whole leg off where the spermatophore was, and he deposits the leg inside of the female, and then he swims away and dies. He's not the only, this isn't the only species that where the male actually, instead of just giving her a spermatophore as a nuptial gift, will give her the arm with the spermatophore. But I don't know if that's the only way that you have two species with such different size ratios can mate, but that's how they do it. And when the female of any octopus species is ready to lay eggs, they are there's a number of different ways in which they can fertilize the egg. So the simplest way is that as the eggs go through the oviduct, they're fertilized by the spermatophore that's already in there. But as I mentioned, she can also kind of reach into her handbag of a mantle and grab the spermatophore or the leg that has the spermatophore. And then after she lays her egg, she grabs that and then fertilizes them, using her arms. And so uh, that is the first instance we have, and it's kind of a weird instance, but it's the first instance of that we see of tool use in octopuses. And for many, many generations, humans have separated humans from the rest of the world because we use tools, and animals didn't use tools. But now we know that that's not the case at all. And this is just, again, one of several examples in which octopuses use tools. But in this case, she's using the male leg as a tool to deliver sperm to her eggs. And then once the eggs are laid, octopuses are just fantastically devoted moms. The male probably this point is already expired. Once they mate, they're pretty much done. She then stays with those eggs and essentially protects them. She circulates water over them. She keeps them alive and happy. And this is done at the expense of her own health because she stops taking care of herself, period. She doesn't eat. She basically hangs out and protects them. That process can be short. It can be a couple months. It can be 9 or 10 months of just sitting there and only protecting the eggs. And then when they're born, they say, "Hi, mom," very briefly, and then she swims away to die. So the tragic story, one of love and devotion, but she's exhausted from basically sacrificing herself. Then when those tiny little cuties hatch, depending on the species, they can grow very, very fast. Again, extremely efficient metabolizers. In some species, they're increasing their body weight at 5% per day. I don't know what that would mean for Marcus, but that's probably, well, we can figure it out. One part of, so again, she is using that leg as a tool. Um, and oh, and another thing that's important to say is that just like starfish, if an octopus loses a leg, it does regrow back. It grows back the same as pretty much the same as it was before. So it's not a total sacrifice from the part of the male, but using his leg as a tool. But that is again the first use, and in this particular species, the male blanket octopus, as tiny as he is, has found another way to use tools as a defense mechanism. So blanket octopuses are immune to the venom of man-o-war jellyfish, and man-o-war jellyfish have extremely potent venom. So it's kind of like the clownfish and the anemone. The male blanket octopus can just basically hang out in the arms of the man-o-war, and he'll go farther than that. He'll clip off a stinger, and then when he leaves the safety of the man-o-war, he will have that stinger as a deadly weapon because the stinger still works when it's not attached. It's a physical mechanism of injecting the venom. And so you can just imagine this tiny little 2 centimeter blanket octopus just, saying, "Hey, stay away from me. I've got a stinger and I'll use it," and kind of brandishes it like a sword. I think I found my new favorite octopus. Tool use in octopuses continues. There is a particular octopus that has found uh, well, there's a lot of ways that octopuses solve problems. And one particular octopus found a pair of coconut shells, coconut halves, and ended up basically taking those coconut shelves with them as like a mobile home. Like, some octopuses are very solitary. They will switch homes every couple weeks, and they usually find a home. And this is a particular octopus that basically found a home that he liked and just continued to take it with him everywhere, like an RV. And determining intelligence in creatures is always a slippery slope, but they have demonstrated all kinds of things that we would call intelligence. So they can solve puzzles, they can work mazes, they can learn to choose colors and then cause and effect. They can open jars, they can sneak out of their tank and climb up into a cabinet and find a jar and open it and eat the contents and then sneak back into their tank as if nothing happened. There are a couple of researchers at the Seattle Aquarium, Jennifer Mather and Roland Anderson, who have determined that octopuses develop their own individual personalities. So in other words, when given the same set of circumstances, you can predict how an individual octopus will behave different from how other octopuses of the same species or even related octopuses will behave. And they grouped 19 different behaviors of octopuses into three major categories: activity, avoidance, and reactivity. And they name their octopuses, of course. So Leisure Suit Larry was described as very social, loved interacting with humans. Emily Dickinson was very shy, just tried to stay away from everybody. And there was Lucretia McEvil, who displayed very destructive behavior no matter what they put in their tank, that she just ripped it apart. So octopuses have their own personality. They also exhibit play behavior, very important. And there was a Natural History magazine article describing octopuses playing with a prescription bottle that was half full of water, half full of air, and they were literally playing with it as if it were like a beach volleyball. Um, they problem solve when presented with clams a lot, and these are a lot of the same experiments we do with crows and with elephants and with dolphins and with octopuses. When presented with a clam that they normally open the normal way, the hinge way, and they're like, okay, this is yummy. Then they presented them with a clam that was wired shut, so strong that even the strong octopus couldn't open it. And it did not take them long to very quickly adapt to use that special papillary drill. It's like, all right, I can't open you. I'm going to drill into you. And even it wasn't just I'm going to drill into you. Pretty soon, they figured out where the weakest spot in the clam was, And so then they always started drilling at that spot, not other spots that were thicker. So uh, definitely something going on in that brain, or should I say brains. Um, and then of course there's Paul. We got Paul the turtle at the Urban Ecology Center. The Sea Life Center in Germany had Paul the octopus. Unfortunately, octopuses don't live very long, but Paul the octopus was extremely accurate in picking the winners of the 2010 World Cup soccer matches. Basically, presented with two boxes, and depending and each box had, I think, the flag of the country that was uh, represented in the match, and did a way better job than the bettors in determining the winners. Um, so I mentioned brains. All of this, what we could call intelligence, is made possible through a complex and large central nervous system and a decent sized brain. Proportionately, octopus brains are as big as many mammals and birds. It's certainly the most evolved out of any of the cephalopod brains, and the brain isn't at the center of the entire nervous system. Each arm or tentacle also has its own nervous system that can act independently from the brain. So if you disconnect the brain in a terrible lab experiment, the legs can still function in many different ways, and they're still ticklish, according to really evil researchers. So it's it's kind of like they have nine different brains. They're not all brains in the sense that, our brain is, but each brain can react, and not just react, can make decisions um, based on the environment. So technically, one brain in the body, eight brains in each leg. So nine brains to go along with their three hearts. And millions and millions and millions of years of evolution has acted on this highly complex nervous system to produce these amazing adaptations that we're seeing. And not just the adaptations, it's the breadth of their behavior. Octopus eyes are also absolutely incredible. They don't always look like goat eyes. They do have musculature around them, so they tend to squint like goats a lot, but they can open them. Um, and octopus eyes are way more efficient than mammal eyes. If you were to design an eye, if you're an engineer, sit down to design an eye, you would not design the mammal eye. We've got blind spots. We've got a optic cord in the way. Uh, we'll get into that more when we talk about squids, because as much as octopuses rule in the intelligence front and other things, squids rule by far in the optics front. The squid eye is amazing, but we do know that, camera manufacturers made major breakthroughs by studying the eyes of octopuses in terms of layering lenses. They capture more light. They have that multi-layered film over the cornea. And if you're going to draw an octopus, even at a young age, you're going to draw those little suckers probably. And the little suction cup, each individual sucker can be attached to as many as 10,000 neurons. So you're combining this amazing combination of precision and strength and dexterity. Um, so octopuses are amazing, astounding, many superlatives. And in some ways, they need it because it is really hard to be an octopus. For all the amazing things, even the big ones, the giant Pacific octopus, which gets up to 600 pounds, from birth to when it's 10 millimeters long, they have about a 1% survival rate. And obviously, the bigger they get, the more their chances of survival improve, like with a lot of organisms. But people do like to eat octopuses. They're very nutritious. A lot of other animals like to eat octopuses. It is a tough life, but they are very adapted. They're tough animals. They can use that muscular siphon to jet 25 miles per hour through water with steering ability. They're loners. Um, they often change locations every couple of weeks, and they're just pretty incredible. And we just know so little about them. And there was so much more. We're 3 minutes away from 10 o'clock here. There's so much more to talk about with octopuses. And I encourage you to look into it a little bit. It's fun. If you want to kill some time and don't want to doom scroll, um, start looking at some octopus videos and read some. There's really good books about octopuses. There's the Netflix series that I haven't actually seen yet, The Octopus Teacher, I think, or whatever. It's gotten mixed reviews. Probably from a human perspective is where the mixed reviews come from. But there's a lot of great books out there, a lot of great articles. It's a really fun organism to learn about, and you could do much worse. So thank you for joining me today. I will stop sharing my screen.